one lament that you will hear over and over and over on the internet with regards to programming your Chinese radios are people who are struggling with their prolific cable, or the cable that I should say is based upon the prolific chipset, and having it not work with Windows. The reason is Windows has a lot of trouble with the clone drivers that exist for the prolific chipset. And this is what a clone cable looks like. And a lot of these problems can be resolved by using a better chip, which would be the Silicon Labs chip, which is available basically online through a lot of sources, very cheap. So we're going to look at how you can build your own Silicon Labs cable, and if we have time we will also cover the FTDI cable, which the RT Systems bases their proprietary cables that works with their software on. You can actually build one of those cables yourself, a little more complicated because you have to flash the firmware. So just to get started, if you want to assemble a few tools in order to do this, you are going to need obviously your little board with the Silicon Labs chip on it, and that's the FT232RL. It's a USB to TTL board is what it is. So you can find that. Then you're going to need a cable, and one source is to take your old cable and break this part and take the chip out, and the chip looks like that. And I don't even know if you can see that. I better check. We'll do close in later on. But you take that out and then you'll resolder in that. So to undertake that project, if you want to start from scratch, you can actually take an old microphone cable with the Kenwood, the 2-pin Kenwood connection on it, and use that as your cable source. Or you can take a cloning cable and cut it in half and strip it and use that. And if you're going to go that route, because the Silicon Labs chip has got a mini USB connection on it, you then will take a mini USB cable and plug it into the other side of that in order to attach that into the computer, and the other end will end up getting soldered on to the cable for your radio. And we'll see that in closer detail. So some of the other things you're going to need to accumulate in order to get this job started would be a good soldering station that you can control the temperature on, so a digital soldering station. And you're going to need probably a vise to mount it in, or a pair of helping hands like this that you see to hold your wire and your chip while you're soldering it. A few other things that you're going to need in terms of tools are going to be some wire strippers and some cutters. So a small pair of cutters like this, wire strippers like this, and you may need coax strippers. There's a coax example, and here's another pair that I use for doing sheets on antennas, strippers like that. Also, you'll need some forceps and some tweezers. And when you want to finish the job off properly, you're probably going to need a heat gun in order to apply your heat shrink, and your heat shrink will be consisting of, I prefer to use a clear dual-walled adhesive lined heat shrink, and then put a label on top of the chip so I can see what it's all about, and I'll know later what it is. However, you can also use color-coded heat shrink. Again, this is dual-wall adhesive lined. It's more flexible and rubbery, and it makes the adapter waterproof. So we'll zoom in and get started with the steps on creating this cable. So the first step on creating the cable is to prepare the board, and because the board has got universal use, it offers a few different interfaces that you won't need to take advantage of, and some of the connector points get in your way. So we're going to deal with that first. And here you'll see this is a jumper to tell the board whether it's going to be 5 volts or 3. Because we're always going to be 5, we don't need the ability to jumper it. So what I'm going to do is solder. I'm going to remove the jumper, and then I'm going to cut the pin that is 3 volt pin, and I'm going to solder together the other 2 pins so they're permanently on 5. And to do that, you will find, first of all, figure out which one is your 3 volt pin. And because I've already done that on one that I had prepared previously, I see the 5 volt side is the left 2 pins when the prongs are facing toward you. So I am going to cut off the pin that is on the far right side. And then what I'm going to do is bend the other 2 pins together so that they're touching each other, like so, using my forceps. And when I have them so that they're touching, I can solder them together. In fact, what I'm going to do is trim them down further so they're not poking up, so later when I put heat shrink on there, it'll be nice and flush. So I'm going to trim those off and then solder them. In order to jumper it for 5 volts after we've cut the pins off the other side, another method is to short these 2 pins on the bottom of the board by jumpering those with some solder or putting a small piece of copper wire across. The copper wire, I'm just going to try this and see if it works without copper wire. There's another method. You can either join the pins on the other side or join them on this side. Now that those pins are connected, the next thing we're going to do is remove the other interface pins that we don't need, and those will be on this particular board. The way they work is the TTL. All we're going to need is TX, RX, and ground. So you can remove the TTL and the data. I believe it's TTL and VC and probably data. Anyway, all you do need is ground, transmit, and receive, TX and RX and ground. So again, to remove those, I'm going to nip them right at the source. So it's the one that's furthest that side, and then it's going to be, I leave those 2 and then I remove the 2 that are in between, so it'll be there and then there. Now I've got the 3 pins left, so I'm going to tin those pins and then I'm going to solder my wire onto those. So we will speed up the video now while I'm tinning this, because I'm sure all of you are better at soldering than me. Now we have them tinned. We're going to prepare our wire to solder onto that. It's worth at this point a little caveat on your choice or the wire you use, because the suppliers, when they build these, there's no requirement for them to have a common protocol for which is red, which pin red and white goes to. So bear that in mind, and you might have to experiment accordingly. So you need to bear the you need to strip the red, white, and the black, and tin them. And it gets a little tricky when you go put those onto your board, because you can these wires are pretty fragile. So here we have the red, white, and black in this cloning cable, which could be different if I was to be using this mic cable, the old mic cable that I robbed this off of a speaker mic that wasn't working anymore, or if you use the programming cable that you already have and you remove the chip. Black is constant, as you're well aware. If you find when you first try to program it after you've done this and it doesn't work, then swap the red and the white, and chances are it's probably going to start working at that point. It's a bit tricky tinning these wires because they are so thin that you have to do it very, very quickly, and you don't use much. And if your hands aren't super steady because you're an old fart, it's even more tricky. So there we go. Those are tinned, and next we are going to need to tin if you hadn't done so already. So when you want to attach to this one with my cable, it's going to be transmit goes, white goes to transmit, and black to the ground, and receive is going to be red. So the black is the one that's closest to you, and you can start out with that guy. Again, just very quick. There we have the 3 wires connected, and we will go on to the next part of this. Just a note, I forgot to put the small dual-walled heat shrink over the cable first, so I had to disconnect it and add my heat shrink that's going to go on there. Then I put on the larger dual wall to act as a sleeve, and in this case I think we'll go with yellow because I have my choice of colors. And then the last part will be to get the clear heat shrink, which is about 12.7 millimeters. It's a tight fit when you use the 12.7 to get over that, and in fact I'm going to go off and find some 15 mil clear dual wall to put on that one. Once you've got all your wires soldered on, before you commit yourself by adding your heat shrink and finalizing that, you better go to your computer and plug it in and try your programming software and make sure that it works first. And so that's where you're going to need your USB to mini USB cable and plug it into your chip. And now your cable looks like this, with USB on one end and standard Kenwood 2-pin connector on the other. And now we're going to head to the computer. So we're going to start. We've plugged our new cable into USB port, and we're going to try it with a TYT UV 8000D and see what'll happen. So we plug everything in first, then turn the radio on, and then go into our software and just make sure we have a COM port selected. The only one that looks like it's going to let us use is COM 6. So we'll say OK to that, and then we're going to go program, and we're going to see if we can read from our radio. You need to hit the OK button in this case, and if everything is copacetic, you'll see a green bar starting from the left. If it's not working, you'll see this window pop up, and it shows that either our COM port is wrong, we don't have the Sil Labs drivers on the computer, or, and which is probably the likely case, we need to go and swap the white and the red wires on our cable and then try again. So I think I'm going to go off now and do that first. Now we've got the cable back on the bench, and we're going to swap the white and the red and see if we have any better luck. Now we're back at the computer after swapping the red and white wires, which is the transmit and the receive, and we're going to check and see if we're on a COM port. It's still on COM 6, and we're going to go see if we can now read from the radio by virtue of swapping those wires. And indeed we're getting the green bar of life, which means that the umbilical between the TYT 8000 and my exoskeleton computer is working fine. Presumably the Silicon Labs drivers were found, and this is Windows 7 that this is working in now. However, I've also had these cables working in Windows 8. So once this is finished reading from the radio, then I can carry on. I can read in my own program files and bring the radio back up again. Reading completed. I think they mean reading complete as well. And the stock radio, as you see, comes with one UHF and one VHF frequency in there, which is all we needed to test it. So now I'm going to go back and finish off this cable now that I know that it works, and I guess it was lucky that I didn't apply the heat shrink before I tested it. You never know. The same two cables from the same two suppliers could actually have the red and the white swapped out. It just depends, so never take it for granted. For this dual wall heat shrink, I like to overlap where I want it to end up. I give it about 2 to 3 mil of extra distance, and it'll retract back to where you want it, depending on how long you apply the heat. The heat shrink and the label. So there we go. Now I let that cool down. It'll solidify in place, and it's going to hold fairly well. And now this cable, as you can see, is now glued into there, so I've got a permanent cable there. If you prefer, you could have the heat shrink further retracted back when you start back here, and then you'll be able to remove this cable In fact, if I pulled on it with enough vigor, that's going to come out anyway. So I prefer just to leave it in there. And now I've got the two ends I need. I've got a Silicon Labs compatible programming cable now that won't give me all the grief of the Prolific cable, and then you won't end up like that. Those are all the Prolific chips that I pull out of any of the stock programming cables that I get from the manufacturers when I get them, because I found it cheaper sometimes just to order the cables from them and take the chips out instead of finding other sources for my cables. So next in the series of videos, we will look at doing the same thing with a more expensive chipset, which would be the FTDI, which can then be programmed through your computer, and you can change the firmware so that you can use it in place of an RT Systems cable. And if you have their software, that cable will then work with their software.